Hey everybody, let's look at some step functions. You've got your parent function over here. This is the most basic step function. We're looking at a greatest integer function, which has this notation right here. And you can see it in other ways as well. This is what you're going to see on the book though. So the greatest integer function is talking about the greatest integer less than or equal to x. So we got an example here, the greatest integer of -1. So here's my x value, -1. So I can get over here, -x, -1 is my x value. And the greatest integer, so the greatest number that is less than or equal to x, less than or equal to a -1. Because you can actually be equal to it, -1 itself is the greatest, the largest number that we could have less than or equal to -1. So it actually has a closed dot here. This one's an open dot. At -2, it's an open dot as in it didn't hit -2, it actually hit the closed dot at -1. And so let's do a couple examples here. If I have the greatest integer of like a 2.3, so the greatest integer, like whole number, that's less than or equal to this 2.3 would be a straight up 2. So now let's look at 1, 2.3, like right here. That on our graph was at the y value, the whole number, 2. So the greatest integer, whole number, that is less than or equal to 2.3 was 2. So that's why it's on this straight line right there. Let's try another one. Let's do the greatest integer less than or equal to, let's do a negative. So like negative 5/3. Do it with a fraction. Okay. That's like a -1 2/3. It's like between your -1 and your -2. So it's like about the x value here. And the greatest integer, the greatest whole number that is less than or equal to that would be the -2. That's why it's on the graph at the y value of -2. Okay, and then any whole number is pretty much going to be itself. So say I choose like a -3. The greatest integer, the greatest whole number that is less than or equal to, it can actually equal the -3. So if you look at the -1, 2, 3, it actually hits the y value, -3, and it's got that closed dot, so it actually hit that point. Okay, so we've had a couple examples of just the greatest integer of x. Now let's look at this one with the 3x minus 1. So if I substitute in a -2, now I'm going to simplify this down a little bit. I get my -6 minus 1. So I end up with a -7 in there, which is a whole number. So I'm going to stick with the -7. Now the 3/4, let's kind of start it out the same way. We're going to simplify what's inside this function. Okay, so I will multiply 3 times 3/4. I get 9/4. I'm going to treat my 1 like 4/4. So 9/4 minus 4/4 is going to give me 5/4, which is basically like a 1.25. So we want the greatest integer that is less than or equal to like a 1.25. So here's my x-axis, 1.25, like 1.25. The greatest number that is less than the 1.25 would be a +1. All right, and 5.9, we're going to put this into our function again. 3 times 5.9 minus 1. Okay. All right. So let's see. We're going to get, so like a 17.7 minus 1. So we're down to a 16.7 in our greatest integer. All right. Then the greatest whole number that goes that's less than or equal to the 16.7 would be straight up 16. And it's kind of off the chart here. I can't really show you on the graph. But that's the biggest whole number that's less than or equal to the 16.7. All right, now let's look at number 8. Evaluate the function d of x equals the greatest integer of x plus 1. So let's try this when x equals a negative 1. So I get the greatest integer of the negative 1 plus 1, which because this is a whole number, it's basically saying negative 1 plus 1, so I get a 0. The integers are usually the ones that we're just going to leave it the same way. Not usually, we're going to leave the whole numbers the same way. So same deal here. Positive 2 is another integer, so I'm going to leave it as a positive 2 plus 1, so I get to a 3. And you can check this out on your graph. If I was doing the greatest integer less than or equal to a positive 2 on my graph, okay, here's the positive 2x value, and it hit right here, which was the y value positive 2. So you can see graphically what it actually hits. If my x is not a whole number now, it's 3/2, like a 1.5. The greatest integer that is less than or equal to 1.5 is your 1. So we end up with another whole number. Okay, so now let's graph this. I'm going to put my x-axis and my y-axis. Okay, and let's get a couple points on here. I'll choose some x's, and then I'll have to find the y value. So I'll do maybe a couple negatives, a 0, a couple positives, and see what this looks like. So 4 times the greatest integer of negative 2 plus 1. All right. I end up with a negative 1 in there, which is a whole number, so great, I get the negative 1, so 4 times negative 1 is negative 4. Okay. So it actually hit this. I'm going to put a closed dot at the point negative 2, negative 4. Okay, closed dot. Now, we will have to have, like you can see if it looks like this, you will have to have an open dot on the right side. You got the closed dot on the left side. All right, negative 1, 4 times. Let's see, negative 1 plus 1 is 0. It's another whole number. So I will leave that 0. So I will actually hit at negative 1, I actually hit the y value 0. All right, and I'm hoping this will be kind of a consistent pattern here. When I sub in my 0, let's see if it does the same thing. All right, 0 plus 1 is still an integer. It's the whole number 1, so I end up with 4 times just the number 1. So I get the point 0, 4, 1, 2, 3, 4. And I think this is pretty much, it's looking like a straight line. It's kind of going up 4 over 1, up 4 over 1. So the next one, let's see if it does that up 4 over 1. Let's see if it gets this point. At 1, I get a 1 plus 1 in there, which is still a whole number. 1 plus 1 is 2. So the greatest integer is going to stay the whole number 2. 4 times 2 is 8. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. Yep, 0.18. Still on there. This will be a 212. It's kind of off the chart here, so I'm going to ignore that for a sec. Let's see how we can make it look like this parent function, though. It should be a totally horizontal flat line here until wherever this other dot was. I'm going to make it go over to that x value, and then I put an open dot. I'll show you what I mean here. I'm going to zoom in. I'm going to make this go over to, let's see, the x value was negative 1. Once I hit the x value of negative 1, I've got to put an open dot there, because then it jumps up to this one, and then it'll have a horizontal line. Oh, maybe I'll put these in another color. So I have a closed dot here, over to an open dot, and it jumps up to this other closed dot. This vertical line should only hit one point. There should only be a single closed dot. And then it's going to be this flat horizontal line until, oh, now I put an open dot because above it is where it actually hits that closed dot. Okay, and then I will put a horizontal line until, let's see, this next x value is at 1, so I should have an open dot at the 1, and it jumps up and has a closed dot. Okay, so this is a transformation, like you've kind of changed this parent function, but I think you'll see the kind of pattern here. It's got this horizontal line with a open dot, like you didn't hit it, and then it jumps up to the next horizontal line, and so on. All right, so these are your greatest integer functions.